Now let us take up a very, very important topic, inheritance patterns. We are not talking about dad's property inherited by daughters and sons. There are some diseases also inherited, specifically to daughter and son it is being written. Now let's look into it. A parent is homozygous and a parent is heterozygous for an autosomal recessive, then what will be the outcome? That means, let us say capital A is the dominant normal allele. Small a is, let us say, a recessive defective allele. One is homozygous means small a, other is heterozygous means capital A, small a. So for this combination, what will be the percentage of getting carrier state, disease state and a normal state? Now let's look into it. The male heterozygous carrier is capital A and small a, and let us say female is also heterozygous carrier is capital A, small a. I am not talking about question, I am talking in general. So that will create one normal, one affected female, and there will be one heterozygous carrier for one male and one female. So there is 1 out of 4 for affected female, that is 25%, and there is a 50% chance to become a carrier, and there is a 25% chance to have a normal one. So similar pedigree, if you try to plot it, then you will get the answer that if the one parent is homozygous, other is heterozygous, then 50% will be affected and rest are carriers is what you will basically recognize. So how do you basically depict a pedigree, doctor? In the pedigree, representation is females are circles and squares are about males. I mean, we must be very careful while deciding the denomination in the modern era of a feminist society, right? So somebody said, I have 3 sons, 1 daughter means, 3 plus minus 1 minus. So that they're all gone days. You talk minus about girls, they will slap you on the face. In fact, finally in the end of the life, you will recognize that sons are not even minus. Sons are divided also. Divisions, not even subtractions. And daughters turn out to be true additions and multiplications. So at the end of life you will recognize that plus minus denomination I made at the time of birth was wrong. So you must be sure in pedigree also what is the representation. Circles are females, squares are males. Small a means abnormal allele, and we will anyway take in the other questions how do we represent. Now what is the inheritance pattern of von Willebrand's disease? There are 3 forms of von Willebrand, and all of them are autosomal dominant in nature, except the type 3, which is a very severe type of von Willebrand disease, which is autosomal recessive in nature. Otherwise all the remaining are autosomal dominant, basically is what need to be remembered. And what is important about von Willebrand? Why you need to remember? The most common inherited bleeding disorder is von Willebrand, not hemophilia. Common mistake done in the exam. We answer it as hemophilia, but that is not the most common. The most common inherited bleeding disorder would be the von Willebrand's disease, is what you need to fundamentally understand. Now what is the most likely pattern of inheritance based on this pedigree? You must be able to decide. Fundamentally, you can see here that an affected father is transmitting the disease to the daughter, and an affected daughter in turn is transmitting the disease to the son and to the daughter. So based on these observations, what is your inference? All females from both the daughters of this affected father have the trait, but not all the males. If you take the 2 males of this affected female, not all males from the affected female have the trait. So there is some sort of a bias. If the father is affected, then all daughters are getting it. If the mother is getting affected, then all sons are not getting it. So that means it is definitely sex-linked inheritance, not a autosomal recessive. I mean, it is not autosomal, and there are no carriers. Somebody has a gene means they are showing disease. There is no carrier state. So somebody has a gene and definitely showing disease means it can only be a dominant condition. If it is a recessive condition, what will happen? If one allele is normal, other allele is abnormal, then it is a carrier state. Disease won't still be expressed. But the mere presence of allele makes the disease to appear means it is a dominant condition. And why it is X-linked? Because all females from the affected males have the trait, but not all males from the affected females have the trait. Hence it is basically a sex-linked is what you will conclude.